Wonderful fifth graders, Module 5, Lesson 19. This lesson's going to look a little bit different because I do not have my protractor. I don't have my ruler with me. I don't have any of scissors with me, any of that with me. So what you're going to do is you're going to follow along in this presentation. So I'm going to go through Lesson 19. Our objective today is to draw kites and squares to clarify their attributes and define kites and squares based on those attributes. So here's your target. I can draw kites and squares to clarify their attributes and define kites and squares based on their attributes. Here is a fluency. If you want to go ahead and pause the video, you can do these fluency problems. Okay, here's another fluency video for you to do. Pause the video. Another fluency, you can pause the video to do this. Here's another fluency for you to do. Remember, these are easy, right? 4,800, it's 48 divided by 1, which is 48. The zeros cancel out. Cancel out your zeros, you guys. Okay, we did our application problem. Okay, the application problem states that Zach is not correct because Kylie's figure is a rectangle and a rectangle is not a square. Their opposite sides are equal lengths and parallel, and all four angles are 90 degrees. Okay, so problem 1, draw a square and articulate the definition. Step 2, you're going to measure and label its angles to explore their relationship. Step 3, measure to explore diagonals of squares. So here we go. Go ahead and draw a square. You're going to use your graph paper to draw a square. Remember, when you draw a square, that you have to have all equal side lengths, right? And then you also have to have 4 right angles and 2 sets of parallel lines. Measure and label the angles. The angle should be how many degrees? 90 degrees. And then go ahead and measure the diagonals. The diagonals of the squares should be the same. Okay? Can a rectangle ever be a rhombus? Can a rhombus ever be a rectangle? Think about what a rhombus is. All right, here we go. We're going to draw together. So look at what we drew down here. This is a square. It is a 3 by 3 square with 4 right angles. So what have we drawn? A square. How do you know? Because it has 4 equal side lengths and 4 right angles. Okay? So on your paper, you're going to do exactly what I did. Draw a segment 3 inches long on your blank paper. Label the endpoints A and B. So that's that top line. You can use a set square to draw 3-inch segments from A and B at 90-degree angles. Draw both line segments toward the bottom of your paper. So you're going to start with angle A, draw a 3-inch line segment down, and then start at your point B and draw a 3-inch line segment down. And then you connect C and D. Okay, our A and C parallel to B and D. They are parallel. So I just told you already to use your straight edge to connect the points C and D. If you use your graph paper, it makes this a lot easier. So you just drew a square, okay? Using your protractor to measure the angles of C and D. We know that their measurements are 90 degrees. So this is a parallelogram with 4 right angles and 2 sets of opposite equal sides. So we can call it a rectangle. So yeah, it's a square, but it's also a rectangle because it's a parallelogram, 4 right angles, 2 sets of opposite equal sides. Since this is a parallelogram with 4 equal sides, it can also be called a rhombus. Very good. So we have a rectangle, a rhombus, and a square. We saw your list of attributes of a square. Okay, then you want to draw the diagonals of the square. So from A to D and then from B to C. Will our diagonals bisect each other? And then measure the lengths of your diagonals to test your prediction. And then measure the distance from each corner to the point where they intersect. And what do you notice? So you're going to measure the diagonals from A to D and then from B to C. You will find the midpoint, and then you're going to measure from A to the midpoint and then from D to the midpoint. You'll also measure from C to the midpoint and B to the midpoint. So in that middle, in the midpoint, you're going to find those interior angle measurements like we have done before. So that midpoint is that point in the middle, and then you find the interior angle measurement. Okay, and we learned if you measured correctly, those interior perpendicular bisectors. All right, problem number 2. We have one more quadrilateral we're going to explore today. It works best outside on windy days. You guys should know this because it was in your target. What are we going to draw? It's flown with a string. It rhymes with bite. It can be found at the beach. Guesses, guesses, guesses. A kite. All right. Go ahead and draw your own kite. If you have somebody at your house with you, compare your kite to their kite. Are they the same? Are they different? What do you notice? Now we're going to draw a kite together using our tools. Draw an angle of any measure with 2 sides that are the same length between 2 and 5 inches. So it doesn't matter the measure of your angle. It could be an obtuse angle. It can be an acute angle. It can be a right angle. Okay, and the sides are going to be the same length between 2 and 5 inches. So if one side is 2 inches, the other side should also be 2 inches. Okay, you're going to mark the vertex as I and the end point of the segments as K and T. So the middle is going to be I, and the end point of your line segment is going to be K and T. Go ahead and use your scissors to cut along the rays of your angle. So you're going to cut along those rays, along the lines, just like shown above. Okay, so now what you're going to do is you're going to take that and you're going to fold the angle in half, matching up the points of K and T. Fold it in half and match up those points. On the fold down below, you're going to mark a dot. So that second picture there is another dot, and you're going to label E. So now we have K-I-T-E, kite. Okay, you're going to use your ruler to connect your point to the ends of the other segments, and then you can cut out your kite. So this is a different picture. Okay, but use your ruler to connect your points to the ends of the other segments. So it just depends, okay? These both are different drawings. So yours can look similar to either one. Doesn't matter. So you're going to connect K to E. You're going to connect T to E. What do you notice about the sides? How are they different from a parallelogram? Use a protractor to measure the angles of your kite. Record the measurements on your figure. What do you notice? Okay, now you're going to draw the diagonals of the kite. Measure the length of the diagonals, segments of diagonals, and where the diagonals intersect. And after you do that, what can you say about the diagonals of a kite? Are they equal in measurement? Is one longer than the other? Where do they intersect? Okay, so what are the attributes of a kite? You're going to write these down. Instead of telling your table, you're going to write them down. You are going to post them to Seesaw. Okay, we know that a kite is a quadrilateral. That's an attribute. It has adjacent sides or sides that are next to each other that are equal. Okay, can a kite ever be a parallelogram? Can a parallelogram ever be a kite? Why or why not? And then when you are done with this, you're going to go ahead and do lesson 19 problem set, just number 1, only number 1. You're going to do 1A, 1B, 1C, and 1D, and you will post that to Seesaw. So today's lesson, I'm sorry that it was very brief. I wish I had my tools with me, but I do not. You drew a square, you drew a kite. We clarified their attributes, we defined them, and defined kites. We can define squares based on their attributes. Okay, and if you look down below, there's some attributes there. So a square is a rhombus. It's got 4 right angles. A square is also a rectangle with 4 equal sides. A kite is a quadrilateral in which 2 consecutive sides have equal lengths, and it also has 2 remaining sides of equal length. Interesting. Okay, so again, a kite, it's a quadrilateral, just like a square, so that's how they're similar. It has 2 consecutive sides of equal length, and then 2 remaining sides of equal length. And then you will do your exit ticket. Number 1, list the property that must be present to call a rectangle a square. Ooh, And number 2, excluding rhombuses and squares, explain the difference between parallelograms and kites. Good luck, everyone.